We are back for our last session of today. This session will answer the question of how do I know whether students have access to strong math instruction? So again, if you are viewing this video asynchronously, and you want to make sure that you have had the previous two sessions, the opportunity myth session and the session on grade appropriate assignments. So if you haven't had those, stop this video and go back and watch those other two sessions first. For those of you that are with us live, thank you for your participation and working through these last two sessions. This session will be more interactive. You'll get a chance to unmute and share some of your thoughts as we look at what makes a strong math instruction, what that looks like in a classroom. So again, for today, we're going to commit to being fully present so that we can engage in the learning together today. This session, like I said, is going to have opportunities for participation. So be ready to unmute and share your mathematical thinking. I think this is going to be a fun session. And again, as we are tackling some of these larger ideas about the findings of the opportunity myth, just want to continue to have that growth mindset and feeling validated in some things, but also challenged in other areas as well to really examine our practices. Quick reminder, this is being recorded, so you want to make sure that you are on mute, and we will have an opportunity for questions at the end, or you can email me with any questions that you have. All right, so you will want to go to this link. This is a different link that will take you directly to the session materials for this training. So Elizabeth will share that, drop that in the chat for you. You can also use the QR code to access the materials, but either one, the bit.ly or the QR code will take you to a Google folder with the handouts for this session. You want to go ahead and get those open now so that you'll have them ready. And this one, I think there's just one handout in this session. All right, thank you, Elizabeth, for dropping that in there. All right, so here we go. So in our first session together today, we shared the 4 key resources that influence a student's school experience and outcomes. The last session we focused on grade appropriate assignments, and this session we're going to focus on strong instruction in mathematics, where students are doing most of the thinking. We saw from the opportunity myth that spending time on worthwhile standards-aligned tasks and ensuring that students are doing the work and the thinking is super important to their success, especially for our kids who are starting the year behind. But what does this look like in a math classroom? So that's what we're going to dive into today, is really look at what should we be looking for when we're looking for strong instruction in a math classroom. You'll get a chance to become familiar with TNTP's tool for measuring mathematics instruction. Again, you're not expected to become an expert rater today. This is just to give you some guidelines. You'll recognize lesson components that engage students and give them ownership of their math learning. And then again, we're going to make some connections to the larger STEM.LD work with our learning today. So those are our session goals. And so math is one of those polarizing content areas, right? In fact, many people in our society have developed math anxiety based on their experiences in math classrooms. Math is either one of those things that people go like, I love math, or, oh, I am not a math person. So let's take a minute and listen to these 2 middle school students share their experiences in math class. I'm going to start playing this video, and Beth, I see you. So if you hear the sound, will you give me a thumbs up? Thank you.
I think it's kind of like prison. When you're like locked up, you have
Hold on, y'all.
to do a certain thing every day, the same homework pretty much, and there's really no escape from it. You have to do the same exact thing.
It's literally in math the same stuff over and over again. We literally have a calendar that instructs the same thing, like Today you're going to do 8.3.4. Tomorrow you're going to do 8.3.5, so on and so forth. You feel like you're stuck inside of the textbook. You're doing nothing else except that. Everything is based around this one thing. Right now, I feel like the math textbook is kind of like the Bible of your grade. You have to kind of worship the textbook in a way to be able to get a good grade, and I don't really like that. The only time we're not learning about the textbook is when the teacher prints off a resource page based on the textbook for us to work on. And that's why it's like a prison. You can't really escape it. You feel like you're serving a sentence for like nothing sometimes.
Okay, you gotta love middle school kids, right? Like they're just gonna tell it like it is. But in all seriousness, can you relate? So that was my experience. I may not have used those words, but when I reflect on my experience as a student, I shared some of those similar beliefs. I did okay in math class, but I surely didn't like it. It was not my favorite class to go to. I saw it as a series of unrelated algorithms and formulas that my teacher showed me how to do, but I had no idea why I was doing it or why it worked or how it was really relevant to anything outside of my math textbook and my math classroom. So this is something that when I speak with others about their experiences, they share similar stories. So when we think about some of the shifts that are occurring in math education and the ways that we can engage kids in math learning, there are really two ways to kind of think about it. So the first way is there's the way that the boys described in the video, right? You show show students methods and then the kids repeat them. So like if you're looking at the algorithm on the screen, right, you do the steps for how to do this multiplication problem and how to carry and what you do with that. But it's a series of steps that are taught to perform a function. Now, this approach is used in a lot of schools. It was the way that I learned mathematics, maybe the way that you learned mathematics as well. But what we notice is that the methods often lacked meaning, and students reasonably ask, like, when are we ever going to use this? Or I don't even understand how this works. Additionally, students only ever get to use what they are shown, not select a method themselves, which is one of the most important mathematical acts. So when we only teach this way, right, there's really nowhere else for the student to go. And if they forget the steps, they're kind of stuck. Okay? Or a second way to think about mathematics instruction is to engage students in rich, open, visual, and creative tasks. This promotes kids using their intuition and thinking and choose methods that can be useful in the task. When they need to learn a new method, teachers can embed these methods inside of tasks so that kids see relevance. They engage in the important act of choosing and making connections between ideas. So what you see on the screen is you see different approaches to solving 18 times 5 and the different types of thinking that these kids did to get their answers. All of these methods are valid and can help kids become more flexible in their thinking about numbers. The algorithm works. There's nothing wrong with the algorithm. But if we only teach them that, then there's really nothing else to learn from that than the answer. If we want them to really think deeply about mathematics, having them explore multiple ways and use their own intuition and judgment to come up with the method that makes sense to them is going to serve them better in the long run. Oops. So the research is pretty clear. Math is the subject that has the most potential to crush students' confidence, but also the most potential to change their lives, giving them the intellectual empowerment they need. There have been studies done that show that children's math aptitude or their achievement in mathematics at the age of 7 is a higher predictor of their economic status when they grow up than any other factor. So mathematics is super important. So if you're a math teacher, like that's a lot, right? It has the potential to change lives, which is super exciting. It's especially important when we think about these pathways to STEM careers. If you think about, we do have kids who shy away from STEM majors in college because they look at that course guide and they see the number of math classes that are required and they decide that they don't want to go that route. So when we change kids' beliefs about what they can do in math, you change their lives. I'm not being dramatic, like that's real, right? That's why this work is so important, and that's why you're so important. But how do we do that? How do we empower kids to be creative and confident mathematical thinkers, especially if that wasn't the way that we were taught mathematics ourselves? So we're going to explore that a little bit today. So in that folder that you opened earlier, you should find the instructional walkthrough tool for what we look for in strong instruction in math. So go ahead and open up that resource if you haven't done so already. And our training today, we are going to focus in on the high quality instructional practices and student ownership. The other two pieces we'll cover in July with your administrative teams, but I'm going to give you just a couple minutes to check the tool out and see what do you notice and what do you wonder about the tool. Okay, I was responding to Philip in the chat. He had a good reflection, a valid reflection that many times teachers feel rushed and feel like they have to teach to the exam, and that is a reality, right? And so as we're going through this session today, and you're experiencing some different ways that math class could look, keep that in the back of your mind and see if at the end we can talk about how might you still be able to include some of these rich experiences and how might that impact kids on their exams? So thank you for bringing that up. Okay, so like I said, we're going to be focusing on the high quality instructional practices and student ownership. So let's start here. What do we mean when we say high quality instructional practices? Well, we're looking for the essential question that we're trying to answer is, does the teacher's instructional practices support all students to learn the content of the lesson at the depth intended by the standards? So it goes back to thinking about that rigor piece that we talked about in our earlier session. Y'all are going to think I'm obsessed with butterflies. Just wait till the end of this session. We're going to talk about it again some more. But here's a look at what do we mean when we are talking about these effective mathematics instructional practices. So historically, math instruction often focuses on teaching students how to get the answer, instead of employing instructional practices that make the actual mathematics explicit for students. So you can see this example here. This is a different butterfly method than I shared earlier. Earlier it was for comparing fractions. This time it's for adding fractions. But the pit here that you fall into is that works for those two fractions, but what about when I start adding multiple fractions together? Then what? Because I didn't learn what it meant to add fractions, so I don't know what to do now. So when we avoid or when we don't teach the conceptual pieces of our standards, these advanced problems or concepts that come out later are much more challenging for kids. They don't have the tools that they need to be able to answer them. So instead, we want to make sure that we are allowing kids, that students are conceptualizing math concepts in different ways. We want to make sure that we are giving them opportunities to look at multiple explanations and representations, and sharing a variety of representations that kids come up with sports solutions, and then summarizing the mathematics to reinforce the focus of the lesson. And this is super important because if you think about it, if a teacher says 3/4 in class, she may be visualizing 3/4 as 3 slices out of 4 of a small pizza. A kid might be thinking of it as like they're seeing 75 cents in their head. Another kid might be seeing 3 red balloons out of a total of 4, right? So you get my point. There's all kinds of different ways to see the value that she's talking about. So making that explicit for kids by showing multiple representations helps them to understand some of the concepts that are going on. So we're going to look for, in high quality instructional practices, we're looking for practices that build kids' conceptual understanding. The second piece that we're going to look at today is student ownership. So we want to see that there's evidence that students are driving their own mathematical learning and engaging in the habits described by the Standards for Mathematical Practice, which provide a guide for how students should engage with mathematical content. So the Standards for Mathematical Practice describe the habits of mind that mathematics educators in all grade levels should seek to develop in their students. There are 8 practices, but we are only focusing on 6 in this tool. And the reason is that we don't actually expect that students are engaged in all math practices in every single lesson, but instead we looked for the 6 illustrative student behaviors that collectively represent the standards for mathematical practice that are most observable in instruction. So one way to think about this and to kind of pare down all of those points is to simply ask yourself a couple questions when you are watching a math lesson or getting ready to teach a math lesson. If you can ask yourself who's doing the talking and who's doing the thinking, that'll help you to start to determine if kids have ownership of the learning or if the teacher does. Okay, so I'm going to show you an example of what I mean by that. So this is an example of an observation that was done in a classroom where a teacher is helping kids to think about how to convert an improper fraction to a mixed number. So the teacher asks, is 7/5 greater than 1? How do you know? Students talk to each other. Teacher calls on a student to share. Well, the kid says, it's big. It is because 5/5 is 1, so 7/5 has to be bigger. Again, the teacher asks, well, how much bigger is it than 1? And how do you know? Another student shares, well, 2/5, because if you take 5/5 out of 7/5, you're left with 2/5. So the culminating question is, so does 7/5 equal 1 2/5? Why or why not? So if you think about this experience, who's doing the thinking in this classroom? And who's doing the talking? What is the role of the teacher in this classroom? I hear a lot of questions from the teacher, but the ones who are doing the actual thinking of the lesson are the kids, right? They're the ones who are coming up with how to figure out how to write this number in a different way, how to represent it in a different way. So I want you to keep this model in your mind of this type of instruction shows that kids are owning their learning because they're figuring it out. And let's reflect on a classroom that looks like this. Okay, same 2 questions, right? If you're looking at student ownership, who's doing the talking, who's doing the thinking in the classroom? So in this one, you walk into a class and there's an anchor chart on the wall, and students are reminded about the story about a cowboy and his horse to help them remember to divide, to convert improper fractions to a mixed number. The teacher gives students 10 practice problems, and they are to go ahead and apply this method to the problem. And then they share out their answers on how they use the cowboy method to figure it out. So if you were to reflect on what might be happening in this situation, we don't see a whole lot of notes about what happened with the kids, but it looks like that the teacher is doing most of the talking and is definitely doing most of the thinking. Kids are applying what the teacher is sharing for them to do. Now, cowboys and horses aside, like right, dividing to convert improper fractions is not wrong, but if the standard demands that they understand why those are equal representations, this method may not help them get there. So if we're thinking about that student ownership piece coupled with that high quality instructional practices, this method or this observation wouldn't show me that kids are having student ownership over their learning. It would show me that they're being compliant and are following a list of steps that their teacher gave them. Okay, so let's put that all together. And this is where I'm going to need you guys, your help. You're going to help me out in participating as a learner in some of these different examples. And when we do this, I want you guys to think about these two, the high quality instructional practices and the student ownership piece. You're going to experience two short lessons on the same topic taught in very different ways. You'll experience them as learners, which means, yes, you'll have to unmute and share, which I think you guys will be just fine with. And then we'll use this tool to debrief our experiences. Okay, so here we go. All right, so today, class, we are going to solve percent problems. Now, there's a really simple way for you to get the answer. I'm going to show you this way because I know that it's going to make it really easy for you and you're going to get the right answer every single time. So we're going to plug the numbers into this over here. So if I want to figure out 15% of 280, all I have to do is plug it into this is over of equals percent over 100. If we do that, you're going to get the right answer every single time. So let me show you how we can do that. So let's get it all set up. Okay, so this is how I can set up, I can plug these values into this over here, and this is what it ends up looking like. That's step one. So now, if you want to solve this, here's what you do. You can do the butterfly, all right? So here we go. We're going to do the butterfly. When I say do the butterfly, in this example, what I mean is we are going to cross multiply. So I'm going to start here and I'm going to multiply 100 and x, and this is what I get. Okay, now I'm going to multiply this. Oh, those are big numbers, but that's okay. I'm going to put them in my calculator and here we go. Okay, so now that I've done my cross multiplication, I'm actually going to divide to figure out what x is. So if I divide this, and then I just get rid of those zeros at the end, right? Because that's what happens when I divide by 100. I'm left with x equals 42, and now I can answer my question. This will work every single time, and you'll get the answer right every single time. So again, here's the steps just in case. You're gonna cross multiply, divide by 100, just cross out those zeros, and now you have x. So I'm gonna give you these 10 problems and let you go ahead and try to figure them out. Okay, we're in scene there, right? Okay, so did you get a chance to unmute? No. So let's do a brief reflection though on this experience. So if we're looking at this through the lens of high quality instructional practices, I am going to ask you to unmute now. What do you feel like? How would you rate this? Would you say it's yes, mostly, somewhat, or not yet there in terms of high quality instructional practices?
Not yet there,
Why do you say that?
because you did all the talking.
No,
I didn't
I
have to
did.
do any thinking.
Yeah, so Eunice, you just hit on the student ownership piece like dead on, right? Like you guys didn't get to own anything. I told you exactly what to do. I was super helpful, like, and my intentions were good, right? I wanted you to get the right answer and have an easy process to follow to get there. But yeah, Eunice, I didn't let you think at all. What else? What else did you guys notice?
That it reflects how we teach most of the time, or I teach.
Yeah, well, thank you for sharing that. And you know what? Like, that's how a lot of math classrooms look. And that's how my math classroom looked when I was a kid. That's how I taught. And when I first started teaching, that's how I taught too, right? And there are things that I reflect on now about, wow, I wish I would have gone back and taught that a little differently. But you're right. This is how a lot of math classrooms look. Philip, were you going to say something?
I don't know if Beth remembers this or not, because it's been a long time. We were in a professional development talking about this exact same method that is over. I don't know. Do you remember this, Beth?
I don't know.
The discussion is that we had spent so much time teaching percentages and trying to get that, because as math teachers know, percentage for some reason is not an easy concept to get people to understand. You drill, you come up with creative, and I'm a big Socratic method guy, and I try that as much as I can. And then you teach that, and then you teach that, and this is kind of the pitfall that people fall into. And those kids struggle, and you can see it on their face. Some of them even cry sometimes. I mean, it's just the way it is. Then you show them the shortcut, and they say this: why didn't you show me that at the very beginning? I don't know if any of y'all have ever run into that or not. Why did you not just show me this? And then, of course, I'm saying, well, I'm trying to get you to conceptually understand this. But then sometimes as teachers, you know how we are, we give up. We to use a Chris Rickerism, we back up and punt. And I think that's a frustration thing for a lot of us, and you're exactly right in saying, you know, that this didn't offer any of the kids this lesson, but that's just my 2 cents on that.
It's very process oriented, very process oriented.
Yeah, it absolutely is. And Philip, to your point, like, I appreciate you bringing that up. Because that is a reality, and helping kids understand mathematics is much different than teaching them how to do a procedure. And when you do get to the procedure piece of the learning, you will have some kids who are like, well, why don't you just do that at the beginning, right? Like, to your point, so in this next experience, we're going to see a different way to teach the same concept. And I want you to think about those kids who might push back and who might be like, I just want to know the quick and easy procedure for this. And how would we respond to that? How would we help them understand that giving them ownership of their learning is actually going to benefit them in the long run? Right. So just to be clear on this one, this would be a not yet and a not yet, right? On either category, we're not there yet. So let's see how this could look. And this is going to require some participation. So be ready. All right, so we are going to explore percents today, and we're going to try to figure out different percentages of 40. So we're going to start off with this one. What is 100% of 40? Someone unmute and tell me real quick.
40.
Yeah, right, 100% of 40 is 40. It's the whole thing. Okay, so we are going to model that on this bar diagram here and show that we've got 100% of 40 is 40. Now let's think about this one. Oops, here we go. What's 200% of 40?
80.
80, how do you know?
If 100% is 40, I have 2 of them.
So kind of like that?
Yeah.
Yeah, so awesome. So you're able to take what you knew, that 100% of 40 is 40, and you doubled it and you got 200% of 40 is 80. Okay, cool. What about this one?
20. It's half the 40.
Half of 40. So what is half of 40?
20.
Yep, because 50% is the same as half. I can represent that here. I can see that I've got some relationships starting to develop here. I see that you told me that that's half, right? So I've got 100, half of that is 50%, half of 40 is 20. That's interesting. What about this one?
And
I'm sorry, what did you say?
10.
10. Okay, how did you know?
If 50% is 20, 25% is half of 50.
Oh, so you use the relationships to show that, okay, so that's halfway between 0 and 50%. That's my 25%. So if this relationship here is between 50 and 25 is half, then I should have the same relationship down at the bottom. So yes, I would have 10. So 25% of 40 is 10. What about this one?
Four.
Okay, thank you for sharing that. So 4, how did you figure that out?
So if 100% is 40, and I divide 100% by 10, I get 10%. So then 40 divided by 10 is 4.
Oh, thank you for that. So you use this relationship here of 100% to 10%. And then you did the same thing down here from 40%. So you divided by 10 and got 4. Did anybody else think of it differently? Or use a different relationship?
I could have divided 50% by 5, and then 20
Sure.
divided by 5 is 4.
Yeah, so you could have used this relationship here between 50% and 10, right? You to get from 50 to 10, you divide by 5, and you could also divide by 5 to get to here. Right, so these relationships are becoming super important to help us represent these percentages of 40, these parts of 40. So let's look at this one. Beth, I see you smiling. What is 5% of 40?
You did 2, sorry.
No worries. Yeah. So how could you figure that out? What relationships could you use to figure that
Well,
out?
if 10% of 40 is 4, then half of 10% is 5%, and half of 4 is 2.
There you go. So I hear again this halving to get our percentages to help us play with those relationships. Now for this one, you're going to need to think about the relationships to help you answer this question. What is 15% of 40?
Six.
10% and 5% added together.
Ooh, I heard an answer and an explanation. So someone said 6, and then I heard someone say, oh, it's 10% of 40, right? Plus 5% of 40, and that's how you got 6. Does that sound right? Yes? Did anybody think of it differently? My model's getting really squished at the end here. Did anybody use a different relationship to help them figure that out?
I didn't, but you could think 25 minus 10.
Oh, what do you mean?
10 minus 4.
So if you took 25, if you know that 25% of 40 is 10, and you know that 10% of 40 is 4, if I subtract those, I'd be left with 15%, and that's how you got 6. Does that sound right?
Yeah.
Yeah. So I can use what I know. If I can figure out half of a number and keep halving that, I can figure out lots of percentages of a number by using the relationships between those so that I can really get a good idea of the size of the number that I'm talking about when I'm talking about a percentage of 40. Would you be able to use these relationships to figure out what 40% of 40 is, or what 65% of 40 is? That's going to be your task right now. So you will use these relationships to help you figure out 40% of 40 and 65% of 40. I'm ending scene there. Thank you for participating in that. So let's reflect. If we are looking at this through the lens of high quality instructional practices, how would you rate this lesson?
Mostly, I would say mostly. The teachers, the last one summarizes the mathematics with references to students' work. I mean, we had student discussion, but you'd have to go on in the lesson to reinforce that focus.
Okay, that's fair. Yep. What else do y'all think?
I think in the interest of time, we only use one representation, but having multiple representations would help.
Yeah, absolutely. So if we're thinking about the importance of the multiple representations, that could come into play here for sure. When you reflect on this lesson, did it focus on the mathematics? Did you see that in there? Yeah, it was pretty explicitly focused on the relationships between values and being able to use that to figure out percentages. There was some opportunity for practice at the end. There was going to be some time for kids to apply on their own. Their understanding of the content was strengthened in this model. And there was a little bit of summarizing, but you're right, like there could have been opportunities for more of that. Now, let's do the same thing and reflect on student ownership. How would you rate this lesson for student ownership and why?
My thought and question is every student getting it and answering? I mean, there was like 4 or 5 of us talking, but if you had a class of 30.
Absolutely. So if I had a class of 30, there might be some things that I would do to ensure that all kids are participating. Like I may have had kids with whiteboards, right, who were making the model and showing me the responses. Because you're right, like I only heard from a few of you in this one. From the kids that I did hear in this one, was the students owning the thinking, or was the teacher owning the thinking?
We were.
Yeah, you guys were justifying and explaining the answers. You were telling me how you figured them out. I tried to allow for people to share multiple ways of thinking because there was more than one way to go at it. But you're right, in these types of lessons, you want to make sure that you have some type of check to make sure that kids are with you, right? And that they are, that they're all figuring out, it doesn't have to be the exact same way someone else thought about it, but that they are understanding that we are taking pieces and how we can use that to help us understand percentages of numbers, okay? So in thinking about those two very different experiences, and a quick little snapshots, right, of what that could look like in classrooms. Let's just take a minute to think about this. So if we want to prepare kids for careers in STEM, we know that they need to become creative and confident mathematical thinkers, not just answer getters. That's what's going to be, that's what's going to prepare them to go into these STEM fields that require the ability to think through and reason around problems that may not have answers yet. So if we only focus on answer getting in mathematics, are we really setting kids up to be successful in these careers? So if not, like if like Philip mentioned earlier, and Eunice, like you guys admitted, this is what sometimes our math classroom looks like. And many times it's because, we're wanting to make sure that kids are successful on their exams. So if we think about this shift in what our vision of excellent math instruction looks like, what are some of your thoughts around that? Like, how would making this shift to a more student-centered model of instruction, how would that help support kids with those end-of-year exams or ACT and ACT, which are important exams? How does this help them?
It's been proven over and over again that when a kid discovers something versus being taught it, they remember it long term. Another thing that I look at, because I teach engineering too, is a lot of kids have trouble communicating and critiquing each other. And that's something that we miss out in math class sometimes, is we've got to teach our kids how to look at other people's work, listen to their work, and add on to it your own ideas and maybe even improve on it. And that's a big part of the design process and engineering and science and everything, is just being able to add on your ideas and critiquing in the right way, and we could do that in a math class.
Yeah, and and not always saying there's only one way to do it. I think
Yep.
that I grew up where this is the only way you're going to get the answer. And if you miss one of these steps, then your problem is wrong. Even though I came up with the correct answer. So I
Yep,
think
that was my experience too. Yeah. Yeah, what else?
I think a lot of STEM is really looking, well, a lot of mathematics at least is really looking for patterns. And so encouraging kids to look for patterns, look for their own way of solving, look for their own shortcuts, if you will. You know, and really, you know, I didn't realize when I went to go get a math degree that was so important until I was trying to do it myself. Yeah.
Yeah, finding those patterns and relationships is really the foundation of mathematics. Like if you were to ask a mathematician like yourself, like that's what math is, right? The study of patterns and relationships. However, math in our classrooms doesn't always look that way. So that's a really great point, that if we shift to this view of mathematics as the study of patterns and relationships, how much better prepared our kids will be for upper level mathematics classes and those STEM careers. Absolutely. And thank you for bringing up the engineer design process as well. Being able to share your idea and then build off of someone else's are essential skills that our kids need to develop. And math is the perfect place to do that. Absolutely. So if this is, this is not a question that you need to answer right now, but just something to think about. So as you think about your campus and your school expectations around math instruction, are they different than what we saw today, as far as like the focus on student ownership and high quality instructional practices? And if they are different, like how do you want to make that shift to a more student-centered math classroom where kids are doing a lot of the thinking? So that's just something that as we leave today to continue to think about. And as we do more work in July with your admin teams, we'll come back and revisit this idea of how to build that supportive school culture that will cultivate these math experiences for kids. So that is our last session for today. Thursday, you're going to get to dive into grade appropriate assignments and strong instruction through the science lens. And then we'll wrap up with a session about high expectations. So again, I'm sorry?
Will we use the same link to come in on Thursday, or will you send another one out?
Nope, it's the same link.
Okay,
It's
thank you.
nice and simple. Yep. So this is attendance survey. I think Elizabeth is going to drop that one in the chat for you as well. There it is. Thank you. This is so you'll get credit for the session that you just participated in. And we do have a couple minutes left. So if there's any questions or anything else you'd like to share about your experiences so far today, please feel free to unmute yourself and share. If you have questions that you'd like to direct us towards me, please jot down my email and I am happy to answer those.
And Krista, I just wanted to add, we received an email, and we certainly didn't know this when we signed up, that if we were math teachers only, that the first two sessions on Thursday were sessions that we would not attend, but we do need to attend the last session. Is that correct?
That is correct. Yes. Thank you for bringing that up. Yes. If you are math only, you don't have to come to the science sessions unless you just want to. But that last session does apply to everybody.
Okay. And I will send an email out because we had signed up for that with our professional development team. So I'll try to send out for Greenville High School what our alternative is for that. And it won't be that day.
Okay. Okay. Yes. Thank you for that. There are things that from the science instruction lens that might be helpful. But there might be a better way for them to use their time for that and then just be ready to come back for that session. So thank you.
Thank you.
Yep. Any other questions or anything that you'd like to share before we sign off?
One thing, we were talking about teaching as far as to develop the conceptual knowledge, which is great at a lot of times, but procedural knowledge is very important too, especially like in the technology and the engineering side of STEM. If you're not following certain procedures or certain steps, you're kind of killing it. Even if you know what's going on, you can know, for instance, how to diagnose a problem on a computer or something, but yet if you don't follow the proper steps. So teaching, conceptual is nice, but you still have to have that procedural skill level.
Yeah, absolutely. And when you think about the slide that was in the last session where it had the three-legged stool, right, of rigor, it had conceptual understanding, procedural fluency, and skills. So that is, if you don't have all three of those, you have a wobbly stool, right? It's unstable. So yes, thank you for bringing that up. There is definitely a balance. What we find is that we lean more towards the procedural and forget and don't spend enough time in the conceptual. And that's why that was the focus of today. But to have a nice balanced rigor stool, yes, you have to have all three of those components. So thank you for bringing that up.
So when you're critiquing your assignments, if you have one assignment that focuses on the conceptual and the other on the procedural, would that break down the level of, where we're saying mostly there or not there, because you're doing two different assignments that aren't hitting both, but it's a lot to cram in if you're just doing both at once?
Right. Yeah. So when you're looking at your assignments, you're rating them against the standard. So if the standard says that it's at the conceptual understanding level, then your assignment should be at the conceptual understanding. If your standard takes it all the way to procedural, then you may have some components of your assignments that focus just on conceptual, and then maybe the next, another assignment later on is focused on procedural. It really depends on what your standard says. So like that third grade equivalency one that I shared, the fraction equivalency, that one is only conceptual understanding at that level. They don't go into procedural fluency until fourth grade. So there should never be a third grade assignment that's only focused on procedural. Does that make sense?
Yeah, I'm a technology teacher, so it's kind of a little different. I'm seeing the math and the science side at the same time.
Yep, that makes sense. All right, well, I'll stay on for a bit. If there's any questions, Stephen, you can go ahead and stop the recording. And thank you guys for all your participation and your wonderful reflections. I had a lot of fun with y'all today. So take care and have a good rest of your day.